My name is Jessica. I'm a PhD student at the University of Pennsylvania, and I'll be talking to you today about our paper, QED in Context, an observation study of proof assistant users. It's a good time to be a proof assistant. Over the years, proof assistants have been used to tremendous effect to verify the correctness of computer programs, with well-known results including a C compiler, cryptographic algorithms, and an operating system kernel. In the past few years, proof assistants have also enjoyed a surge of popularity in the mathematics community, especially due to the Lean prover and its mathematical library MathLib. And of course, proof assistants continue to be a recurring character in your friendly neighborhood PL paper, which might include a mechanization of the paper's results. An important technology like the proof assistant needs to be usable. There's lots of folklore knowledge about proof assistant usage, but for people building these kinds of systems, we need a more robust understanding. Our paper aims to do just that. We present an overview of proof assistant usage that is shaped by the results of our qualitative user study. This overview is carefully organized. There are many overlapping, entangled processes and subprocesses involved in proof assistant usage. We provide a structured way to think about these, so that this paper can be a starting point for getting a sense of what it's like to use a proof assistant. We also share a lot of concrete data. This includes examples that users encountered with real proof snippets, counts that show how widespread a pattern was, and lots of context about what users were thinking and saying. We hope that this results in a catalog of usage scenarios that future tool builders can draw from for inspiration. I'll now share with you a bit about our study methodology. Our study had 30 participants. Half of them used Rocq and the other half used Lean. We observed each participant for about 1 hour. Our median participant had a few years of experience with their proof assistant. And since we observed participants doing their own work, we saw formalization projects from a large number of domains. We chose to structure our study around observing real proof work in real time. The particular approach we used is a well-established methodology in HCI research. It's called contextual inquiry. Let's talk about what contextual inquiry looked like for our study. The sessions were Zoom calls with the participant P and the observer O, that's me. We asked the participant to do the work they normally would, while screen sharing and narrating. One important thing to know about contextual inquiry is that it calls for the observer not to observe silently, but instead to take advantage of the fact that we are there in real time and observe as an apprentice would. This includes interjecting to ask clarifying questions, such as, "Why did you do that just now?" as well as offering our own interpretations and asking the participant to confirm or correct them. Using the recordings, we transcribed each session, including both what was said and what they did, and we qualitatively coded the data by tagging snippets with themes. So what did we learn from all that? We organized our findings into 4 perspectives on proof assistant usage at different levels of resolution: proofs in motion, conversing with a prover, proof sources and resources, and beyond QED. For each perspective, we'll share just a slice of what we learned. The first perspective we call proofs in motion. We were able to observe, in live motion, what it looks like for proof writers to incrementally develop their proofs, often in iterative and nonlinear ways. One source of nonlinearity was context switching, when proof writers temporarily skip their current goal and work on another part of the proof instead. This might be done on the fly, for example, to jump to an easier goal or a harder one. Or the proof writer might deliberately start by sketching the skeleton of their proof, leaving holes to be filled in later. When proofwriters engaged in this micro-interaction of context switching, they implicitly relied on a very powerful feature of the proof assistant, its ability to resupply the proof state on demand. One participant remarked on this explicitly, saying that context switching is much cheaper in a proof assistant than on paper. That's because on paper, contextual information is just in the back of your head, and then if you switch contexts, you forget what exactly was in the back of your head. These examples and others show how proofwriters leverage proof assistant feedback to facilitate their proof efforts. Of course, using a proof assistant is not all sunshine and roses. Our second perspective focuses on difficulties proofwriters encounter when trying to speak the proof assistant's language. A frequent source of difficulty is precision. Proofwriters often have to spend time getting the details of their proof script precisely right. Consider this example. This proofwriter wanted to do case analysis on the length of P. But in the base case, they encountered a proof state that looked roughly like this. The information that P has length 0 is missing, so the goal is impossible to prove. After some fiddling, the proofwriter decided to pivot to a different approach. What would have fixed the problem? and H:. Now, there are many possible diagnoses of what went wrong here. The proofwriter noted that this is not a tactic they use frequently, or maybe the issue is with the documentation, or maybe the design of the tactic itself. The thing I like about this example, though, is that it adds some color to what we mean when we colloquially say that proof assistants are difficult to use. In particular, not only do proof assistants require precision, it does so sometimes at the granularity of characters. Even though we are observing individual proofwriters, often working on individual developments, they still made frequent and substantial use of existing proof sources and resources. This included both relying on existing mechanized proofs, for example, searching for lemmas, or reusing proof snippets, as well as bridging the modalities of mechanized and paper proofs, for example, translating from natural language proofs or doing some scratch work. We see in this section that proofs build on proofs, and experienced proofwriters know how to do so effectively. Our fourth and final perspective is a bit different. Now we look beyond the process of simply getting to QED and examine what qualities proofwriters value in their proofs. But let's pause for a second, because you may wonder, if the proof assistant is checking the proof, do proofwriters actually care about anything other than compilation? They do. We saw many examples of proofwriters making subtle but intentional choices that reflect what they value in a proof. If we only looked at the before and after of the choices proofwriters make, we might not know how to interpret them doing things like adding a word that has no visible effect, or choosing between two tactics that both solve the current goal, or even flipping the sides of an equality. But because we were able to talk to proofwriters about their decision-making in real time, we were able to learn that they wanted to improve the maintainability by localizing future failures, that they wanted to communicate their mathematical intent by opting for a more specialized tactic, and that they needed to follow the conventions of the library that they were contributing to. We can't necessarily tell by just looking at a finished product, but proofwriters often invest careful thought and effort into how they write their mechanized proofs. Okay, let's zoom out again. Our paper's findings are organized into 4 perspectives. Proofs in motion, how proofwriters leverage proof assistant feedback to engage in iterative, nonlinear proving. Conversing with the prover, the sources of friction that arise when trying to speak and understand the proof assistant's language. Proof sources and resources, how proofwriters build on existing proof work. And beyond QED, that proofwriters care about how they express their proofs. Of course, what we've covered today is only a subset of what you can find in our paper. We talked about context switching, though we also observed proofwriters iteratively revising their specifications and extracting lemmas in the middle of a proof, as well as engaging in small-stakes trial and error. We talked about issues of precision, though we also observed proofwriters encountering difficulties with understanding what the proof assistant was saying, such as due to the complex proof states or confusing error messages. And of course, we also go into much more detail about how people utilized existing proof work and the considerations they had beyond QED. The final thing I want to convey is that if you like looking at tools from human-centered perspectives, hello, I hope you consider looking into proof assistants. In particular, we hope that our paper might be useful to folks interested in people and proof assistants in a few ways. For those that don't know how proof assistants work, our overview can help onboard. For those with existing intuition about proof assistant usage, we can help them add complexity and nuance to their understanding. And for those building tools, our examples can help serve as inspiration for case studies. Thanks for listening, and I'm happy to take questions.
All right, thank you. And the authors are online?
Yes, I'm online.
Testing, can you hear me? Okay, so...
Hear us? Can they hear us?
Can you hear us?
I can hear you, yes, sorry.
Okay, excellent.
All right, go ahead.
Very excellent overview. And you can interpret my question more conservatively or go completely blue sky with it. Based on what you've seen, what do you think could be done to improve the usability of theorem provers?
Sorry, I'm just processing the question. You asked based on what there's an echo. Can you hear the echo? Okay. Yeah, so based on what we've seen, what we think could be done to improve the usability of proof assistance? I think sort of I'll give you sort of a more fuzzy direction and a less fuzzy direction maybe. I think a more fuzzy direction, one thing that I've long been interested in is sort of what would it look like to reimagine a proof assistant to be optimized for exploration, by which I mean things like trying to iteratively figure out what definitions you want or how you want to approach the proof. I think there's this interesting tension where, on the one hand, proof assistants are really good for iterative, nonlinear, exploratory kinds of proving because of the sort of automated, instantaneous, up-to-date feedback. But then there are also, of course, ways in which proof assistants are really bad for exploratory proving because of the sort of high burden having to deal with all these unimportant details that are especially unimportant during the exploratory phases. So I'm interested in figuring out how can we reconcile these things. I don't know. If you figure it out, please let me know. And something less fuzzy, I think there's lots of things to be done from sort of pedagogical perspectives on making proof assistants easier to learn. I think one thing that really stuck with me is the participant was talking about how when you're usually learning a programming language, you can learn some building blocks or some general principles that you can then compose into being able to write more complex programs. But proof assistants, tactic-based proof assistants, have a feature where you have to learn tactics on a tactic basis because it's sort of black box things, and that has interesting sort of pedagogical effects. And there are also sort of really interesting, challenging processes like lemma extraction and lemma search, to give examples that I think are interesting to delve into further. I hope that answers your question. Feel free to follow up afterwards if it doesn't.
I think it's great someone is looking into this. It's super cool. I was wondering if you found any difference between the way, say, a mathematician approaches proofs, someone who has a lot of experience writing paper proofs, and computer scientists that maybe learned proofs by just using Rocq or Lean.
Yeah, so differences between how...
Sorry, Jessica, the internet is... Can you turn off your camera? Maybe
okay.
The sound would be much better.
Can you hear me any better now?
Yeah, much better.
Okay, sorry about that. So the difference between how a mathematician who's used to paper proofs would write proofs versus a computer scientist, I think that's actually quite related to what we're looking at currently. In the context of the QED context study, I don't know that we've really sort of collected data exactly along those boundaries. I think, let me think if there's anything interesting I can say about that yet. Yeah, I think that wasn't sort of a dimension along which we really made comparisons. I think it's a really interesting question. I think there's various ways that you could sort of format a study to a more targeted study of that question. There's sort of the natural sort of differences between Lean and Rocq, for example, where Lean is sort of more mathematician heavy at the moment and Rocq is more computer scientist heavy at the moment. And so I think there are comparisons that could be made there. And then, sort of various other study formats, some of which we're attempting, about sort of how people's different backgrounds and relationships with paper proofs affect their experience with proof assistance. Yeah, I think it's a really interesting thing to look into.
Thank you so much for the talk. This is such great work. My question is maybe a little abstract, but if someone were working on tooling for proof assistance, what is the one thing you would like them to constantly keep in the front of their minds as they're doing it from everything that you've learned?
Okay, so if someone were working on tooling, what is one thing they should constantly keep in mind while doing it? I think it's that I think it's that sort of proof-assistant users tend to have a lot of knowledge about sort of how to approach their proof and how to use their proof assistant. And so even when they are struggling to sort of complete the detail in exactly the right way, that doesn't mean that they're 0% of the way there, right? They're actually probably like 80, 90% of the way there. They might know exactly what tactic they're supposed to use, what sort of proof strategy they're trying to go for mathematically. They might understand, like sort of broadly speaking, what their problem is, but not exactly how to fix it. And so I think sort of ways in which we can design tooling to leverage the sort of things that proof-assistant users already know about their problem and potential solutions to it would be interesting to me. Sorry, that's maybe an answer that is abstract as a question. But I think to be a little more concrete, I think, given the recent emphasis on automatically generating proofs, I would be interested in sort of what would it look like to make maximum use of what people already know about their proof assistance and their proofs.
Very cool, thank you.
Last question.
Thank you for the work on something that the community really needs, which is the ACI aspect of theorem proofers. I was curious about the interplay with the lemma searching or proof search. So I'm talking the suggest tactic in Lean up to just using LLMs or even the Lean GPTF tactic. Did you see its use, or did people try to use those searches before doing it manually, or the other way around?
Just to make sure I processed your question, so asking about lemma search and proof search from sort of like automated tactics up to LLMs.
Exactly.
Yeah, so we definitely saw a lot of people using like what we called proof resources to engage in, for example, lemma search. Lemma search took varying levels of automation from sort of, the standard Rocq search tactic, for example, which is very much requires the user to construct their own query, to something like Moogle, which is Lean's sort of natural language-based search engine. So we definitely saw some of that. In terms of like language model or things like Copilot, we saw like a few instances of Copilot. I think 3 participants used it. We did sort of make a deliberate choice not to sort of focus too much on the Copilot instances, both because there weren't that many of them, and also because we think that like a more targeted study would have been better there. So the answer to your question is, like, we saw certainly a lot of lemma search and searching for things generally, a little bit of sort of more LLM usage, but not that much.
Okay, thank you so much.
All right, great. Right, so let's conclude the session. Let's thank Jessica again for the great.